13-8. We get into, now we want to determine, I think really we're kind of determining whether or not our sample size is big enough to represent the population. When we're doing this, kind of my interpretation anyhow, and so it gives us some data. Yeah, 8's relatively simple, or 7 is, and it gives us some data, and it says the following hypothesis are given. So our null hypothesis is that the little p, which is called rho, I don't know, they're using Greek stuff here, and it kind of makes me wonder, if maybe that's why Greek's going to hell in a handbasket right now. Greece is, because they can't pronounce things right. Little p and pronounce a rho. Anyhow, so whether rho is less than or equal to 0, or that rho, and the alternate hypothesis is that rho is greater than 0. So we use the formula that's provided for us, that nice little formula that's on page 437 towards the bottom, the t-test. We're back to t-test, right? So we have to first determine what our critical t value is, right? And in this case, our correlation, which is given to us, 0.32, okay, and that's the R, okay, and our n, our sample size is 12. Our degrees of freedom is n minus 2, okay. Don't know why we use the n minus 2. I don't know if they explain that in there, but that's what we use for our degrees of freedom, and so that's the number that we're looking for. And for you guys, it's in the back of the book on about page 734, I think it is. Yeah, 734, maybe 735. Okay, and because it's greater than, okay, and our hypothesis is less than or equal to for the null and greater than, then we know it's a one-tailed test, and our significance level given to us for number 7 here anyhow is 0.05. So it's 0.05, one-tailed test, 0.05 for a one-tailed test, okay, and 10 degrees of freedom. So my t-value is 1.812. And so I'm going to reject this, I'm going to reject the null if the calculated t-value is greater than the critical t-value of 1.812. And here's my formula, okay. My t is simply equal to my r, or my correlation value, times the square root of n minus 2 divided by 1 minus r squared. So we can just go through those, and I do the square root of n minus 2, which is really our degrees of freedom then, right? So all I have to do is do the square root of the degrees of freedom. Hang on, square root, okay, this one, okay, and then take times r, times that value there, so it's equal to this times my r value. Okay, and then I went ahead and did the bottom of it, so I got 1 minus the r squared. Okay, so I've got it, first I figured r squared, right, is equal to r, boom, to the second, and then I do 1 minus that, okay, and then I do the square root of that. And again, we could do the square root, I guess, either of 2a's. We can come here and square root of this. Okay, then I just have to divide. This is the top part, and this is the bottom part of my equation, so I just have to divide one with the other, I guess we would say. Oops, let's escape that. We don't want to goof that up. Come down here and say it's equal to this one divided by this one. And there we have. Does that exceed the critical t-value? The answer is no. So we cannot reject the null, and thus we cannot conclude that the correlation is greater than 0. There you have 13-8.